let's continue on the following parts of this wall anchor. I just wanted to update you is all the past the code have been updated into the GitHub. So if you come to GitHub, you can go see this folder, master OpenSCAD, and now we are working on this second part. So we already have 5 snapshot model. So last model is this one. So from here, you can read those, you can download, and starting from any snapshot states. So that I hope it can give you some convenience when you learn along with my video. And now we will continue do the this following part to add these booleans, the things. So the inner is we have defined until this 0.3, and let's make this color equal to 0.1. Color is relative length of initial non-slit part, and the slit equal to 0.5. Slit width. Last is the cap size equal to 2. Length of the hand-arm. So we still keep this outer DM, no change. And the side length is okay. And after all those, we have a linear extruding for the base, and we have our translate and the union for this part to remove, and now we have the second part to remove is the slits. ABS color equal to length times color first. Then we have a loop I equal to 0, 1. So just the 2 loop. And we will do this, let's see, the loop is for cube. We have a cube with the 3 sides. So first one is the side length plus 2. Just ensure is when you shift that you have this one as the buffer. So slit as the second, so that's not a semicolon. And length minus cap size minus ABS color. Then we have our close parenthesis. So let's see, we have one thing. So let's let me see whether I can have this one only. So that is the highlight for what we just built, and then we will make this our rotate. So first is translate to 3 dimension. So one is the minus side length plus 2, then divided by 2. Second is minus slit half. Then with the ABS color. Then with the base. So we can see what happened. We move days and the cube. So what's the arrow? Side length. I put this as side length. So no arrow. So it just translate a little bit. So, and then we rotate that. Rotate 0, 0, I times. So we need this tool. So this one. So if I don't have that, you can see here, you have rotate this. So two parts. One is rotate on this, and another is rotate on this. The two direction. Then we delete this or remove this from the original this shape. So then that's is the empty. So if you put this into the transparent, then you can see clearly. So what you have done is you create two this cube on this this two direction. Then is you use this difference to cut that. So as we make this now, we have this shape on hand. So that is our number 5, and keep saving a new. So we will move. So here you see it's also mentioned is you can examine that with this pound character. And in order to able to grip while in a drilled hole, we now want to give our wall anchor some teeth. So keep adding the more the perimeter. So teeth D is equal to 5. Divisor. Teeth divisor determining the number of teeth. So now you can imagine is why I put this 3 default already here. So that's I always keep here is empty. That's working. So try to use this way if you like. Teeth depth is 1.5. Depth of the teeth. So let's see how we can see the teeth. Teeth also removed from the material. So we already have the color, and we have let's see. So what's the color? 3 ABS color length. So times color, and then here this one is this. So we need to continue remove something. So teeth count. So if floor is the round, so we count is to the this integer, not a decimal. So length minus ABS color. So we use this ABS color in slits. Divide by teeth divisor. So just for the troubleshooting purpose, or just for the this have the reference purpose, we can echo 2. So one is the teeth count with the floor, and another is without floor. Let's see. So how pair syntax. So echo which line? 15. So teeth divide. What's the syntax? 15. Oh, so again, so that is my fault. So now you can see we have echo. So echo is just 9. So and flow is 9. So then that is no difference. So, but if you don't have flow, if that is decimal, then that will be difficult for us to use later on the for loop. So that is a way is you can leave this just as the kind of the debugging purpose. Then we will have the t's distance, length, minus ADS color divided by the number of t's count plus 1. So now we have the 2 parameter about the t's, and we will have opposite. Is the outer dm minus the outer dm times the outer taper divided by 2. Hypotenuse is a calculation like a triangle. Power of 8 2 plus power length 2. Then we can have this angle is A sine opposite divided by hypotenuse. Press F5 without arrow, so you can continue. Then diagonal distance is the square. If you don't familiar with those the triangle related formula, you can read earlier the part, or you can also read from here. Then that's give you some mathematical this background. So I don't go detail for those parts. Now we have enough the parameter on hand. We can starting to make our these t's. So the t's is working from here. So for this one, then we rotate and rotate for this. It's just one sentence. So you can see here, all the things is coming from this cube. So let's starting build from the base. So cube, let's make this focus, outer dm. So we can have an idea is what's this actually built. So outer dm is here. Outer dm is this one. Drill hole dm is this 8 plus oversize 2. So outer hole dm is 10. 10 in 3 dimensions, 10, 10, 10. So then what we are doing, so first we rotate this in y are 45 degrees, so it should be coming to this part. So 0, 45, 0, but it's the positive y, so should be from it's like this. So let's see our imagination. 0. So no change on this cube. So let me put here. Yeah. So I need to highlight this one. So it's change. And then so keep adding things. We will translate to 0 and minus y, so it's going come to our side. So let's see, minus outer GM divided by 2, and z is 0. Yeah, it's half. So move 5 to here. Then this one is done, and we keep adding one more. Rotate, and rotate on Z. So you can imagine on Z is this direction. So it's this. So rotate 0, 0, minus 40. So minus 45. Come to this way. So now is we have this square or the cube, and translate. So what I'm doing like here is just let you see step by step what your model is making. So if you just read from book, it's not so direct or dynamic here. So minus this ABS column plus 1 plus I times piece. Yes. So let's highlight this. So let's see where it's going to translate. So we have this one now. Now let's see. It's getting dia ABS column this diagonal disk. Let me read. Here is the 69. 69. Oh, yeah. So I try to use I, but actually the I should be this loop. So let's change that. No, this I. So look like it's coming to some higher. So I is from 1 to t's count. So let's say 2 is higher. So it just keep adding and thing. Remember, is your base shape is here. So you will delete from here. So this edge is look like a knife. So that will be gradually remove that. So if we don't have this one, you will see here is cutting from here. If I have 3, then is this one. 4 is this one. It's getting smaller. Is because you have the scale, not the same size from bottom to the top. So that is looks like more realistic. This teeth in the reality. So now is we put this I, and we will have our for loop here. For I equal to 1. Actually, you can also have 1 here as the step, but 1 can be the ignored. So let's see if I put this here. You got kind of these things, and then we will make these 4 directions. Then it will cut your shape one by one. So that is this part. And if we put your base shape in, so you can see that is gradually cutting here. And then next is we will rotate for this angle. This 1, 1, 0. You can see here. So what's the difference now? So let's look at this. So without this rotate, so let's see. So let me put this as well. So if I make this Control D, so let's view. So you just have from here rotate a little bit inside, because you need to make sure is this teeth length not impacted by this scale. So now let's remove this and uncommon this. So that's why the OpenSCAD is by this scripting is very interesting. Is you can step by step to make your desired model. So now we have this rotate, this one, and we need to rotate more. So we rotate. It's a 0, 0. Let's see, I put this 90 first. So I gave this one. So you see now it's coming to here. And if I go to the 180, it's come here. 270 is come to here. So that's the reason is we need to have this 4 altogether. So we define our J, and then the 4J equal to, that is the degree. So step is 90 degree. You should not have a 360. You should have 359. So that is not overlapping. So when we have the our highlight, so we have this 4. Actually, you made this 4 knife, and then this 4 knife, the effect is cut from the 4 direction and through this rotate with this angle, and you have this the teeth in the same line, same depth. So that is the step by step on this this part. Let me save. Then we have one more the step to finish to have this, but it's already approaching to the end. So you have the hole and you have the external one. So compared to our this target, is already this one on hand. Just changing the shape, we can make that into the second one. So this then in this 07 final as a final touch, we want to give you special wall anchor, the option to have a round instead of a square. So that is let's see when where we have here the difference. So this is the circle. Let's see what's the difference with any others. So if no difference, then let's see, here is 0, 0. All are same, and these are same. The only difference is we are adding a circle. So here, so on the hole, before the hole, when we did this, we will add our the condition. So linear, square. So first is side length. Is we will have our check. So equal to round shape. If round shape, then we will do the outer EM. So we don't need to do this the calculation. If not, we will do that. And then we should add our boolean. So round shape. So equal to false. So by default, this gave us this the rectangle. So make the anchor round instead of square. So let's just test. So nothing changed because we make this false. And then let me see here. So if I put this round shape, equal to true. What's the happened? So equal to true, then it's still the square because I didn't change the second part. So linear. So if that is round, a round shape. So this means if round shape, it means it's true, and else is the let me see, if round shape, I will make a circle. Circle is a diameter, is the side length, and you can make this face number. I gave even bigger, so I gave 100. 100 is better. Then else, I have my square. So now if I put that here, so you can see this is the second part. So we can have both. So I can make R translate. So now these are the X, Y, Z. So I put that in the 0, 30, 0. Now I have another one, wall anchor. By default, it is the square. So now you see I have a 2. So if you change on this way, so how to shift this easier. So now we have these 2 parts altogether. So this one I hope is to make you understand some idea on this extruding. So we only use linear extruding, but remember you can also have this rotate extruding, and when this you think is finished enough, then you can press this the F6, then they are starting to make the rendering. Since I don't have the large the phase number, so now it's easier for us to export to this STL. So once you export to STL, so you can come to put this come to the GitHub. So two ways, as I mentioned in the tutorial. So in the VS Studio, the VS Code, you have the I think is there's our extension code is STL. So VS Code STL Weaver. Once you install that within the VS Code, you can directly view this. If you don't use the VS Code, you can come to the GitHub. By default, they also support the STL preview with also nice view on the GitHub directly. So if I put in here, you can zoom in and you can look at this, and they will automatically rotate for you compared to this VS Code. That here is also the quite the interesting, and you can see this wireframe work. This, and you can examine the inside, and you can see the surface angle to understand this whether they have the big change on this the angle, and also this solid. So keep watching on this repository to get all these snapshot model file. And also from the bottom, you can download this complete file from this book. So thank you for watching on this. Now we finished the second project. Next project, we will move to this Windows anchor. Windows stopper. So this one is if you miss some of your current Windows stopper is correct, then you can crash. So you can make this 3D printing yourself. So that is more closer to your life, and we will play this in next video. See you then.